example 1, we have 8 factorial over 5 factorial. Remember that I said it is not compulsory that you take the product until it gets to 1, depending on the context of your question. And you can see that this is a fraction. You have 8 factorial over 5 factorial. 8 factorial can also be expressed in form of 5 factorial so that they can cancel one another. So if you want to write your 8 factorial, you can express it as 8 times 7 times 6 times 5 factorial over 5 factorial. With this now, 5 factorial can cancel 5 factorial. So what do you have left? You have 8 times 7 times 6, and that is what? 56 times 6. 56 times 6, what is it going to give us? It's going to give us 336. 56 times 6 is going to give us 336. So what this means is that 8 factorial over 5 factorial is equal to 336. Now let's look at example 2. We have 10 factorial times 5 factorial over 11 factorial times 3 factorial multiplied by 2 factorial 3 factorial over 5 factorial 6 factorial. So what do? We look at what can cancel one another. From the question you can see that 5 factorial can cancel what? 5 factorial. So we have 3 factorial can also cancel what? 3 factorial. So we are left with 10 factorial times 2 factorial over 11 factorial times 6 factorial. For this, 10 factorial, because we have 11 factorial as the denominator, so we can express 11 factorial as a form of what? 10 factorial, so that it can cancel the one that we have at the numerator. So in this case now we can say that 10 factorial times 2 factorial over 11 times 10 factorial. Remember that we also have 2 factorial at the numerator, so we can express our 6 factorial as a form of what? 2 factorial. So in this case now, instead of writing 6 factorial, we'll say that times 6 times 5 times 4 times 3 times 2 factorial. I hope you are getting it. So with this now, 2 factorial will cancel 2 factorial. 10 factorial will cancel 10 factorial. So we'll be left with 1 over 11 times 6 times 5 times 4 times 3. So what would this give us? 11 times 6 is 66. 66 times 5 times 12. What do we have? We have 66 times 5. That will give us 330 times 12. What would that give us? So that will give us 3,960. So we have 1 over 3,960. And that gives our final answer. Is that? Yes, we have 1 over 3,960. Now, let's move to permutation. Permutation is the arrangement of objects in a definite order. And the permutation of R objects from N objects can be expressed as this. When we say permutation, is the way at which you can arrange an object. It depends on the kind of object that you have. You can have yellow, blue, green, purple objects, and you are asked to arrange them. Or you are asked that in what way can you arrange those objects. So, based on your opinion, so you might try to start with purple. Some other people can start with yellow. But what matters is how many arrangements can you have from those different colors. You have blue, you have green, you have yellow, and you have purple. In how many ways can you arrange these objects? If you want to represent it in terms of permutation now, if they ask you that, in how many ways can you represent or can you arrange these 4 objects? What do? You just count the objects. 1, 2, 3, 4. 4 factorial. Remember that we have done factorial before. So 4 factorial, this is This invariably means that you are saying 4 times 3 times 2 times 1, right? So you can arrange these 4 objects in 24 ways. This is what permutation is telling us, that in how many ways can you arrange an object? And in permutation often requires us to take orderliness into consideration. The order of the objects matters a lot, unlike combination that you just pick, you select. But for permutation, if you start the arrangement with P and eventually you are still having BGYP in that arrangement, it does not count as, for example, if you have PGYB. PGYB is not equivalent to BYGP in permutation. But in combination, PGYB is the same thing as BYGP, because in combination you select. If you are selecting 2 people, it's still that 2 people that you are selecting. But if you are arranging, of course the arrangement differs. That's why they say in permutation you have to put the arrangement of that object in consideration. So when you are counting, you count them independently. They are not depending on one another. PGYB is not the same thing as BYGP. It's not the same thing as YGPB, and so on and so forth. So now, what is the mathematical representation of permutation when you are trying to arrange a particular object from an object, from n objects? If you are trying to arrange R object from n objects, it is usually expressed as n permutation R, which is equals to n factorial over n minus R factorial. N factorial in this sense is representing the total number of objects that you have. And then R is telling us the numbers that you want to arrange from those objects. Are you picking 2? Are you picking 3 out of those objects for arrangement, and so on and so forth? So now let's look at this example. If you want to evaluate 7 permutation 4, what do? Since we already have a standard mathematical representation, so just substitute your values as you can see here. From this example now, your n is representing 7 and your r is representing what? 4. So what do? You say that 7 permutation 4 is equals to what? 7 factorial over 7 minus 4 factorial. And that gives you 7 factorial over what? 3 factorial. Remember I said that you can represent a number in another form. Abi? You can represent a particular number as a form of another number, depending on what you have, the context of what you have. So I can represent 7 factorial as a form of what? 3 factorial. So you can say that 7 times 6 times 5 times 4 times 3 factorial over what? 3 factorial. I'm doing this for a particular reason, and the reason is because I want to look for a way to eliminate this 3 factorial that I have down here, right? So that is why I decided to express 7 factorial in terms of what? 3 factorial. So with this now, 3 factorial will cancel 3 factorial. So what do you have? You have 7 times 6 times 4 times 5 times 4, and that gives us 840 ways. I hope that is clear. So now let's quickly move to the second example. The second example, we have 8 permutation 3 plus